Hello and welcome back to the August update from the Testnet team. Without further ado, let's get into the development team side of things. So over to you, Karim.
Thank you, Fola, and welcome everyone to the Tau Development Team update for the month of August 2025. Andrei has successfully completed the persistent chain state milestone M7 that he set for himself. To accomplish this milestone, he had to refactor how the blockchain manages its state. He removed the old snapshot-based approach and reconstructed the state directly from historical blockchain upon startup of the node. This significantly improves the fault tolerance and reliability, potentially at the cost of extended startup time. That's why he also worked on streamlining the node startup process, and he also conducted thorough testing to ensure stability and correctness of the whole process. David this month has been working on allowing variable bit width bit vectors. The difficulty there is the ability to operate and mix bit vectors of different widths, as well as detecting overflow conditions when they arise. The core part of the system is a scope to union-find data structure that allows for the inference of bit vector width of variables and constants. He also added the new syntax for specifying bit vector widths and variable and constant definitions. And of course, he added many unit tests to make sure all rules are executed correctly. Apart from all that, David made several improvements in the treatment of bit vectors. In particular, the shift operator now supports bit vectors as write-up parents. He also cleaned up the code by removing all remaining references to the old Z3 set solver. He also changed the bit vector operator precedence to match that of regular logic operator. On the documentation side, he made updates to the documentation to reflect all the changes that were done to the bit vectors recently, and also revised the Docker file that enables the building of the CVC5 set solver. And finally, this week, he's been comparing the performance of the CVC5 when in dealing with Tau formulas, typical Tau formulas, when in two cases where it's linked to GPL libraries and linked to LGPL libraries. And with some help from Lucca, he also fixed an issue that Andrei had run into when using temporal formulas. And finally, he also resolved another issue with the REPL when invoking variable bit vectors. Lucca has been assisting Tomáš with the tree switch work. He fixed literally dozens of small issues that arose after the conversion of the code base to the new tree API. He also implemented the new Tau input stream called the this stream. He also enhanced normalization to account for type information. And all of these tasks are basically in preparation for the next major milestones, which is the implementation of the anti-premixing algorithm that Ohad has recently specified. Last but not least, Tomáš, with some help from Lucca, as I mentioned, has managed to finish debugging all the issues in the tests that came up after the switch to the new tree implementation. In particular, he fixed the transformations of variables to captures. He's also fixed several critical issues regarding Boolean algebra type propagation and fixed point detection. He also fixed issues with triggering hooks while transforming a parse tree. And finally, he fixed input and output variable resolution. And from now on, the only remaining task is to make caching work simultaneously with garbage collection, which is actually a tricky task. That's it for the development team for August. Thank you very much for listening in, and back to you, Fola.
All right, fantastic. Thank you for your overview, Karim. Let's get right into the nitty-gritty. Over to you, David.
Thank you, Fola. Hi, everyone. This month I've been working in allowing multiple bit widths in the bit vectors formulas. The core part of the system is an scoped union find data structure that allows to infer the bit vectors width of variables and constants across the formulas. Bit vector width could be now specified in variables and constants, and I have added tests to check everything. Minor questions remain to be done in the REPL. Apart from that, I have made several improvements in the treatment of bit vectors. In particular, the shift operators now support bit vectors as right operands instead of numbers as before. I have cleaned up the code, mostly the remaining parts related to set3 and also unnecessary methods in NSO factories. I have reviewed the documentation to reflect the changes done to bit vectors, and also I have made few changes into the Docker file so we could compile with CBC5, which was something pending from the previous month. Also, I have changed the bit vector operators precedence to follow to follow the ones we have in the logic operators, and I have upgraded code to use the latest improvements in the parser. This is just a first step to unify the two main branches we are working on right now, which is the one related to bit vectors and the one related to the new tree implementation. Regarding fixes, I have made a fix. I have fixed an issue that goes a crash when we have mixed type and interpreted constants in the formulas. Also, I have fixed an issue related to the duplication of outputs while solving bit vector formulas. And I have made another fix in the code because we have an issue with loopbacks when dealing with bit vector formulas. Now I'm working in comparing the performance of CBC5 for our kind of formulas, depending on the libraries we choose to compile it. I'm working also in an issue that Andrei has detected when using temporal formulas, and also just dealing with minor REPL changes that I commented before. And that's all for my month. Thank you all for listening. Back to you, Fola.
Wow, super exciting. Thanks, David. And now I'll pass it over to Lucca for his update this month.
Thank you, Fola. Thanks everyone for joining. So this month, the main part of work has been in integrating the new tree implementation into our main branch. So over the past few months, Tomáš has gotten the new tree implementation ready and integrated it into the main places of usage within the whole engine, basically. However, the APIs are slightly different, and there were some parts where the translation didn't work out as we expected, and as a result, there were some quite, you could say, difficult to fix bugs that arose from this transition to the new tree library. And this month, me and Tomáš have been working closely together to get everything up to speed. And we are happy to see that this work is almost at an end, and that the main branch will soon switch to the new tree implementation, which brings, among improved developer experience, also an improvement in the memory footprint and in the speed of the overall execution. Though this is not an exponential increase, of course, so formulas that didn't run before are likely to still not run. However, the memory allocations throughout the solving process, the normalizer process, the interpreter process, they are all very optimized now. Apart from that, I've also worked on implementing the this input stream for the interpreter. This is basically a stream which allows to print out the current specification that is being run. So if you update the interpreter with a new specification, this is then reflect an interchange in the value in the this variable basically. Yeah, and last but not least, I've enhanced the normalization process. Now that there's more type information available, we are making use of this because with the new tree implementation, there came also the new type inference algorithm. So now all terms in the tar language that actually need types do have types, and as a result, we can now properly distinguish all variables, constants, streams, and so on. And I made sure that the normalization process would not cause or would take these additional information into account in order to avoid potential type problems, which could occur before or mainly because our variables weren't typed. But of course, as soon as bit vectors will come into the game and we have more types in one formula, this was a much needed improvement in order to avoid possible mistakes. And yeah, that's basically been my month. Thank you very much, and I'll pass it back to Fola.
Incredible stuff, Lucca. And for now, I'll pass it over to Andrei for his update for the month.
Hello everyone, I'm here to share some of the progress I made with the Tau Testnet Alpha development. Last month, I successfully completed the next milestone on our roadmap, and that is the persistent chain state. What does it do? Now, our blockchain is able to reconstruct its current state from the historical blocks, from the ground up, from the genesis block up to the most recent block. This is very important because when the node exits or node want to ensure that the state is correct, it can restore it block by block, transaction by transaction with all the new rules and all the transactions implemented from the very beginning to the most recent ones. And it involved a lot of communication with our Tau development team because it relied heavily on pointwise revision, since we were adding a lot of new rules and we had a lot of issues we had to overcome there, and we did. Now I'm conducting even more tests. I'm writing more tests to ensure that we have a solid foundation of a blockchain node before moving to our next milestone, and it is P2P networking, when different nodes will have the ability to communicate with each other. So, looking forward for the next milestones completed. See you next month. Take care. Bye.
Thank you so much, Andrei. Now I'll pass it over to Tomáš for his update this month.
Thank you. Hello, everyone. This month, I focused on fixing all the failing tests after switching to the new tree structure and API. I fixed the bit size calculations for the A-type field in the tree node. I fixed transformations of variables to captures to work properly with our write system. I fixed ref-type inference, especially for main formula, and also I fixed issues with updating the ref to its resolve type. Then I fixed existential versus universal quantifiers priorities in Pretty Printer, which was causing wrongly placed parentheses. Then I fixed issues with returning a fail state from hooks, and I fixed type issues by disabling hooks when transforming parse tree. I fixed input-output variables resolution, and I've added auto-resolving of I/O variables with names starting with letter I and O, and built-in streams. I fixed detection of failed triple tests. I fixed retrieval from history when used as an argument to a REPL command. Fixed tests which were using old zero-based indexing when referencing history. And then I focused on finalizing BA-type inference. I fixed an issue in detection of a fixed point in the type resolver, and I optimized the propagation loop a bit. and I removed scoping of temporal variables. That's all for me. Thank you.
Lovely stuff, Tomáš. Thank you so much. And as always, last but not least, over to you, Ohad.
Yes, I continued working on the temporal extensions of the Tau language. One front is to extend the setting beyond omega categorical languages to fixed point languages. It's still not sure that it's gonna work out. We also found some problem with the previous derivation, which I hope to fix. I didn't fix it yet, but it only affects those extensions. It doesn't affect the core Tau language or anything that we learn. And I also worked on some new extensions that allow to look back in time in a limited way, and this may be used for writing solvers for knowledge representation languages. And that's basically all.
A lot packed into a very, very short time. As always, I had. All right. And that about wraps it up for the August development team call. Thank you so much for tuning in. As always, you can find us on our socials. That's Tau_net on X or Twitter. That is TauNet AGRS on Reddit. And that's TauNet on Telegram. Cheers. We'll see you soon.